thirst and disease. For millennia, this has been the lot for the residents of Puglia, born in a hard, arid land that Horace himself called Sitibonda, or parched. For hundreds of years, the life of Puglia's few inhabitants was linked to wells of often brackish water or to cisterns to collect rainwater, cisterns that were full in winter and empty in the summer. In the 19th century, peace and stability tripled the population, upsetting the precarious centuries-old balance. The lack of water became an emergency. Cholera and typhus began to plague these lands. In the early 20th century, the government, trying to fix a now unsustainable situation, promoted the construction of a large aqueduct, at the time Europe's largest. This unprecedented project was based on an ingenious idea: to capture the waters of the Sele River at their source and, by dint of an enormous engineering effort, to channel this water, which normally flows into the Tyrrhenian Sea, for 300 kilometers all the way to the Adriatic coastline. 4,000 liters of water per second ran through the center of the town of Pavoncelli. And so it was that, thanks to the efforts of approximately 22,000 workers, the Pavoncelli tunnel was dug and lined with brick. It took 20 years to cut through 12 kilometers of very low-quality terrain. When the works were completed, the tunnel was already showing its first cracks. 23rd of November 1980, the Irpinia region suffered an earthquake close to 7 on the Richter scale. Pavoncelli was destroyed. It was a terrible blow for the Pavoncelli tunnel. The water supply was interrupted for several days, and even after it was restored, the damage and collapses continued. The discharge dropped from 6.3 to 4 cubic meters per second. For 1,300,000 inhabitants in Puglia, water once again became an alarming emergency. In 1986, the decision was made to build a second tunnel parallel to the first. It was called Pavoncelli Bis Tunnel. But in May 1992, the excavation works, begun from Vallone Acqua delle Brecce, encountered increasingly substantial water inrush, which soon prompted the suspension of the works. To seal off aquifer outflow, a concrete plug was built, but a tunnel section about 200 meters in length was flooded. 4 more times, with different companies, attempts to resume work were made, in vain. The technical and geological problems appeared insurmountable. At last, excavation began again in 2012 with the utmost determination and renewed commitment. Caposele Scarl, a joint venture established by the Italian firms Ghella, Bianini and Giuzio, deployed its wealth of experience and its most cutting-edge technologies to finally put an end to an emergency that had been ongoing for more than a century. To divert the water to the Pavoncelli Bis tunnel, an access shaft was dug, 12.5 meters in diameter, to intercept the existing Rosalba tunnel, which runs 20 meters below the surface, and to build a control chamber. The water was shut off for a mere 25 hours as a diversion structure equipped with gates was built. Works resumed at Vallone Acqua delle Brecce in an effort to get the most out of every meter so as to install the necessary machinery and complete the work as quickly as possible. The decision was made to use the surplus water from the Cassano-Irpino aqueduct, about 700 liters per second, to generate electricity. The conduit meets the Pavoncelli tunnel in the heart of the mountain, 70 meters above. An intake chamber was dug out of massive limestone. The penstock running from it powers 2 Francis turbines. Upon leaving the power plant, the water is carried to the Pavoncelli bis tunnel. To restore the flooded section and continue with the excavation of the Pavoncelli bis tunnel, a shaft about 50 meters deep was dug to allow access by underwater technicians to inspect the tunnel and remove the ferrous materials that would hamper mechanized tunneling. The flooded section was filled with special cement mixtures. At this point, excavation of the 8-kilometer Pavoncelli bis tunnel can resume using an EPB TBM designed to operate safely and efficiently in the presence of methane gas and in all the formations traversed, formations that by their lithological, physical and mechanical nature have very different characteristics. As it advances, the TBM faces a constant barrage of difficulties and dangers, such as, for example, the methane gas present in the mountain in explosive quantities. To eliminate the greatest risks to workers and to be able to dig quickly and safely, innovative automatic control systems have been developed, especially for this machine, allowing gas leaks to be more carefully monitored and managed. The material to be excavated is quite heterogeneous and includes hard rock. This is why the TBM, although small in diameter, provides considerable digging power and has a multi-purpose rotating cutter head. With its highly conical shield, the machine can be easily removed from the grip of thick clay pressing in on it so it doesn't get stuck in the event of sudden stoppages. All these devices, along with the tunnel's small size, make for truly restricted space, both inside and outside the tunnel. The difficulty of maneuver makes everything extremely complicated. For its strategic importance and technical difficulty, the excavation of the Pavoncelli bis tunnel is one of Italy's most important challenges in underground civil works and engineering.